Today we will discuss a few problems relating to physical properties of crystals. In particular, problem 1 is about working out the non-vanishing components of the elastic moduli. For the tetragonal point group for bar. We know that the elastic modulus is defined as the ratio of the stress to the strain. We also know that the stress and the strain are second rank tensors. So, the elastic modulus which relates them is a tensor of fourth rank. And the defining equation is something like this. Where I, j, k, l run over 1, 2 and 3. Even though technically this has 81 components, 3 to the power 4, the symmetry of the stress and strain tensors reduces the number. The symmetry of stress and strain reduces the number of independent elastic moduli through relations such as C I j k l equals C j I k l equals C I j l k equals C j I l k, etc. Now, in addition to this point group symmetry of the given tetragonal point group 4 bar reduces these further, and we can tell which will be the non-vanishing elastic moduli just by inspection. For this, let us label the axis, the x, y and z components will be labeled as 1, 2 and 3. So that for 4 bar symmetry, it is easy to see that 1 goes to 2, 2 goes to -1, and 3 goes to minus 3. That is, x goes to y goes to minus x, and z goes to minus z. That is the meaning of this. Therefore, when you have a component like sigma 1 1, that will become 2 2, and sigma 2 2 will become 1 1, because there are 2 negatives. So, it will become 1 1. 3 3 will become also 3 3, and 1 2 will become minus 2 1, 1 3 will become minus 2 3, and then 2 3 will become 1 3. And we have already seen that there is an abbreviated notation in which 1 1 is written as simply 1, and that becomes 2, and 2 becomes 1, and 3 becomes 3, and we know 2 3 is 4 and 1 3 is 5, and therefore, and 6 1 2 is 6, and that becomes minus 6. Because of this, in abbreviated notation, the Cij/Kls are just written by as C11 etc. in abbreviated notation. And we already see that 1 1 will be in the abbreviated notation, it will become 2 2, and 1 2 will become 2 1, 1 3 will become 2 3, 1 4 will be 2 5, 1 5 will become minus 2 4, and 1 6 will become minus 2 6. In the same way, we can work out and so on. So, this means that in the elastic modulus tensor, we have C11. I am showing the matrix elements by the positions here in an array, and there are 6 positions here. This is the second row and so on. Now, we have seen that C11 becomes equal to C22. This line shows that 1 1 and 2 2 are equal, and therefore, are no longer independent. So, in the same way, we can check the others, and the result that we get is this is C1 2, and that simply becomes 2 1. So, it just goes to it, but they are not equal, and therefore, this and this remain. Then we find C3 3, 1 3 becomes 2 3. So, these two are equal, and then in the same way we can check that this will be the same and this will be there, but these will vanish. For example, C14 becomes C25, but C25, for example, if we work, it will become minus C14. So, it can be the negative of itself only by vanishing. So, these are components which will vanish. By an into across, I mean the vanishing components. So, these are all vanishing. And this C16 will become negative of C26. Therefore, these two are equal, but a negative sign with a negative sign. So, they are equal in sign, but opposite in magnitude. So, that is shown by an open circle here and a closed circle here, and then these are also vanishing. One can readily check that these vanish too. And then these vanish too, also this. And then I have C44 being equal to C55 and C66 is here, and then these are all vanishing. So, that will be the overall situation in which this is independent, these two are equal, therefore, not independent, therefore, there is only one of them. Similarly, here, here, and this is not equal, but opposite in sign, but still they are related. This is also related. So, these are the only non-vanishing components. So, this is how one arrives at this situation. We will work out one more problem of this kind, where we will go from a tetragonal point group symmetry to a complete isotropic cubic symmetry. So, let us take the point group symmetry corresponding to an octahedral symmetry 432, which is a cubic. By the same procedure, we have a four-fold axis now instead of a 4 bar, and by following the same procedure, it is very easy to check that the number of non-vanishing components is the same as result non-vanishing components for just 4 symmetry or the same as for 4 bar. But then in addition we have a 3-fold symmetry. So, we will consider the result of this. The 3-fold symmetry will change 1 to 2, 2 to 1 and 2 to 3 and 3 to 1. Therefore, 1 1 will become 2 2, 2 2 will become 3 3, 3 3 will become 1 1, and so on. So, in abbreviated notation, this is 1 to 2, 2 to 3, 3 to 1. So, we can the abbreviated notation, this is the abbreviated form. So, this goes to this, and because of this 1 1 will become 2 2 in abbreviated notation again. Then 2 2 will become 3 3 now, and 3 3 will become 1 1. In other words, the components in this array C11 and C22, which were equal, now C33 also becomes equal. So, all three are related. Proceeding in this way, it is straightforward to verify that this also happens for C44, C55 and C6x. So, we show the connection between them, the equality by this, and then we have the same situation for C12, C13 and C23, all of which are connected. And the same thing happens on this side for C C21 and then C31 and C32, all three are connected, and all the rest of them are 0. Then this comes here. That is the overall picture, and therefore, the addition of a 3-fold axis to a 4-fold axis reduces the number of independent elastic constants drastically, and leaving only one set C11, C22 and C33, all of which are equal, and C44, C55 and C66, all of which are equal, and then C12, C13 and C23 which are equal. So, only 3 elastic constants which are independent from a total of 81. So, this is the final picture resulting from the cubic symmetry. So, this shows the power of symmetry, the influence of symmetry to reduce the number of independent elastic constants. So, in the same way one can work out the non-vanishing components for other physical properties, other tensors quantities of different